thousands of years ago, you understand how much they are custodians of the memory of the world. Skyway Monte Bianco and Aiguille du Midi are not just cable cars. They have a higher mission, bringing everyone closer to the mountain, both the experienced mountaineer and the old or disabled. 2,000 meters of ascent to be amazed by the marvel of nature, to understand that each of us, every single individual in the world, is responsible for it. To do this, we need concrete actions, daily and continuously by everyone, in addition to corporate activism, individuals and companies that want to invest in the present and the future. At the foot of Mont Blanc, a first step in this direction has been taken. Thanks to the support of Fonevia Monte Bianco, Compagnie du Mont Blanc, Civia Trading and Grival. It is the cleaning of an area in the glacier around the Col del Gigante, where a lot of waste has emerged, revealing the passage of man over time. For these companies, sustainability means developing economic business models, respecting the environment, promoting territorial development and the growth of their employees. A new partnership was born at the foot of Mont Blanc, with the common goal of being united along the path traced by nature. These actions are summarized in 3 words: save the glacier.
This is the way to the peaks of the stone giants, tall and severe, that scrape the sky. This is the way to climb 1 meter at a time and to dance in the continuous movement of the changing shadows. This is the way to rise and rise again, feeding the eyes, never thoroughly satiated. This is the way of the green woods, the gray stone, and the candid glaciers. In the presence of these perfect places, we leave everything behind, because this is the way we can fly.
Okay. Hello, everybody. Nice to meet you again in a virtual way again. Unfortunately, we are very happy also to be in a wonderful place because, as you could see, we are on Mont Blanc Skyway. Of course, we are not on the edge. It is just the first step of the Skyway in Pavillon. We just could say hello or well, salut to our friend on the other side, French friends. But actually what I had to say is good morning, good afternoon, good evening to all the world. So I'm very happy to introduce our second Lectio Magistralis. I just would like to remember that Magistralis means master, and so I'm very glad to introduce Professor Roberto Azzoni from Milano University. We asked him to present to show which are the cause and the effect of global warming. You had a data mining test yesterday, but you have also today and tomorrow a Earth System project on this subject, because we know the importance of this problem concerning not only ice melting, but a lot of other problems. Just 2 days ago, here on Mont Blanc, a part of Mont Blanc collapsed with the hostel that it was on this rock. So we are very worried about the situation, and we believe that we must absolutely recognize the serious problem that global warming is. Unfortunately, even in Italy, we have a lot of people that do not believe in that. But as there is a lot of people that don't believe that Earth is round and just they think that it's flat. Well, I'm going to introduce a professor, but just take 2 minutes for a technical communication. So we are going to have on Monday morning a meeting, but it's dedicated in honor of Mary Anning. It means that are particularly invited the colleague, the women that are working in this IESO, because we just want to see earth science from a bit different point of view. So we will receive the Meet link, and again, sorry, we are going to have on Tuesday, always a midday, a technical meeting, a jury meeting, as we had all the time in occasion of the final days of IESO, just to check how we evaluated the test of the student. The goal, of course, is to show you if we had problems, because we are checking test by test, answer by answer. And just keep the philosophy of IESO and IGO. It means that all the participant country deserve to have an award. So we have to evaluate the number of golden medal, 10% or maybe something more, the silver medal, and the bronze medal. So we are going to, I give you another meet just for Tuesday midday, 12 in the morning. Well, that's all. So thank you so much to Professor Razzoni, and I leave the microphone to him. And I remember that he is going to give us a suggestion, not solution, for your Earth Science, Earth System project, but to open our mind to this big problem. So thank you, and thank you to you.
Thank you, Susanna. Good morning, good afternoon, and good evening to everybody. Ciao a tutti. I'm Roberto Azzoni from the University of Milan. I'm a researcher, and I'm working on the impact of climate change on glaciers and in all the high altitude areas. So not only glacier, but in the all mountains of the world. In this first slide of my presentation, I want to spoil all the results of the presentation. I want to say that I don't want to convince you that climate change exists, doesn't exist. This is the spoil of the entire presentation. There is unequivocal evidence that Earth is warming at an unprecedented rate, and the human activity is the principal cause. Okay, I can finish here because this is the main outcome of the presentation. So I don't want to bring some proof for convince you that the climate change exists, that climate change has effects in high mountains or all around the world. The climate change is a topic that is clear. The evidence are clear to the scientists, to the researchers. How we find these things? Did you know that when you publish a scientific article, not write your article and publish on a journal that you want, but your article is submitted to this journal and have a peer review process. So researcher like me or like in your field read your paper and try to correct the results of the paper. So it's a peer review process. So the results of a scientific research for the climate change, or not only for the climate change, are corrected from other researchers. So the evidence are not written in the morning when you drink a coffee and publish. Okay, you find that the heart is round. Oh, good. No, there is a stronger peer review process that you can find in this cartoon, and is very, very complicated in some cases to accept the paper. And this evidence of climate change, if we took in consideration all the papers about climate change accepted in the last 10 years on the scientific journals, we can find that you can find on green the papers that are according to a climate change, and in red the paper that doesn't that say that climate change doesn't exist. So if we take in consideration the last 10 the publication of the last 10 years, we can find that at least more than 98% of scientific production agrees that there is a climate change and there is an anthropogenic climate change. So in this free slide, I put the milestone that the climate change exists, no doubt. It's not an opinion, it's a real fact. The situation and the facts that there are many people that not agree with climate change, or say that it's not a climate change, but is weather changes that occurs in some part of the world, but is a sort of a cycle, is given the fact that Earth's climate has changed through history in a very wide in a very wide moment, in a very wide way. If we consider the last 800,000 years, so if you are geologists say that it's the day before yesterday, 800,000 years, there have been 8 cycles of ice ages and warmer periods. So in 8 cycles that the Earth was the glacier go down the valley, and 8 cycles that the glacier retire on the mountain. The last ice age was about 1100 years ago. That is a very short time, marking the beginning of the modern climate era. So, okay, we are talking about the climate change now, but I say you that we have more than, in only less than a million years, we have 8 cycles of ice age. But what are the causes of this climate change? The causes of the climate change is simple, because there are in the past, and I mean in the past, there are some variation in the position of the Earth in the orbit of the Earth to the Sun, in the position of the obliquity of the Earth axis, and in the position of the in the modification of the position of the Earth axis. Can these changes can modify the incoming energy on the Earth, causing climate change. Okay, this is the cause, and these connections of these movements are called Milankovitch cycles. Milankovitch was a researcher that find these outcomes from these orbital parameters. Milankovitch says that these cycles have a strong importance to understand the long-term changes in Earth climates. So with Milankovitch cycles, that is, we can try to give an explanation of these big 8 huge variation in the climate, but in the past, not only. Now something has happened, and we can see here in the pavilion, see outside the windows. Okay, so the climate change is not given by this variation of orbital cycles. So we must find another factor that can modify strongly the climate. Sun and solar activity maybe can be. There are long time observation of sun, in particular of its sunspots. Some people say that solar activity is variable over the time, and this variability in solar activity can affect the climate change. You know that since the 17th century, Galileo Galilei, that is the man that you see in the slide, observed the sunspot. The sunspots are on the sun and try to estimate the count of this sunspot. So if we try to correlate, we try to count this sunspot, we observe that in the last 400 years, we can observe 3 periods that the sunspots are at a minimum. This sunspots at minimum is connected with a period, short period, from 50 to 100 years, not long period, that are characterized by a cool temperature, so not a warming but a cooling phase. But if we try to correlate the activity of the sun with the climate change, the situation doesn't fit. In fact, the variation of this the sunspot cycle, so the activity of the solar of our sun is try to variate only the 0.1% of the solar constant. So is not so did not give an evidence for climate change. If we consider, in fact, in the last 2000 years, 150 years, if we consider the average amount of energy from the sound, that is the yellow line, and the temperature, that is the red line, we can see that there is no a correlation, in particular in the last 70, 60 years. The activity of the sun, so the solar irradiance, came to a minimum of the last century, the last 2 centuries, and the temperature rise. So also the sun is not the cause of the climate change in this period, in the last 2 centuries. Physicists try to model the impact of these changes in solar irradiance in the global warming. You can, in this table that it's quite complicated, I want to highlight 2 things. On your right, you can see the parameter that cause an heating of the climate. On the left, you can find the parameters that cooled, that produce a cooling of the planet. If we consider only the last the change in solar irradiance, so the changes in the activity of the sun, we can see that the movement, the radiative forcing of the change in solar irradiance for the heating of the sun is very visible. So we want to model the future climate considering only the solar irradiance, the model doesn't work. So also the sun is not the main component. The sun activity and the variation of the sun is not the main component of the climate change. Okay, not the variation in the cycle in the orbital parameter, not the sun, greenhouse gases. Greenhouse gases, yes, are the main cause of the actual climate change. The greenhouse effect is a positive effect of our Earth, because if we don't have greenhouse gas, if we don't have a greenhouse effect, our world was completely frozen, and was a good thing for glaciologists like me, but not for the humanity of the mankind. The greenhouse effect is sorry again. The greenhouse effect is given by the presence of three main carbon dioxide, methane, and nitrous oxide that create. The sunlight reaches the Earth. Some energy is reflected back in this place, and some is absorbed and re-emitted in the space. This re-emission, obviously, was this energy re-emitted was absorbed by the atmosphere and caused the warming of our atmosphere. These three, carbon dioxide, methane, and nitrous oxide, are the main greenhouse gases that enforced this warming effect. This warming effect was controlled for billions of years by natural phenomena, volcanism, principally volcanism, and other external factors modify the concentration of these greenhouse gases. But in the last millennia, something has changed. I present you a graph that is a famous graph, one of the famous graphs of, if we talk about climate change, that present the concentration of carbon dioxide in the last 800,000 years. And we can see in this graph that the concentration is not constant. The concentration of carbon dioxide have a cyclical, or not precise cyclically, variation, with some years that rise down and after with different period decreasing. We observe in the last part of this graph that something have completely changed. That if we consider a situation, a curve, then there is something that bring out of control this concentration. Okay, step back. Why? I present you data of concentration of CO2 in a million years ago, from a million years ago. How I can present you this data? Because a million years ago we don't have actual possibility to measure the concentration of CO2. This data comes from the ice. These are data obtained in Dome C. Dome C is a research site in the center of the Antarctica. Is I think one of the worst places of the world for living, because the temperature outside varies from -80 to -30 Celsius degrees. So it's not so comfortable to live here. But it's very interesting to research here, because the glacier is a cold glacier. So the ice in the ice is clearly visible the strata of snow, and consequently of ice that recorded that recorded the concentration of CO2. So these data are obtained from this site, that EPICA is the project that this is the CORIN project that permits to obtain this data. EPICA also permit to researchers to obtain a concentration of methane, and this graph is not so famous as the CO2 concentration. Methane is not so considered, but the greenhouse effect of methane is very, very high, and is higher than the CO2. And as you can see from this graph, the variation and the increasing in methane concentration in the atmosphere in the last years is more impressive than the CO2 concentration. So in these data are try to explicate us that there's something that have changed during the last million years in a cyclically way. Now something has changed in a very faster way. This the importance of CO2 data and the importance of CO2 measurements for considering the variation in greenhouse gases is given important in the last 60 years, not before, thanks to this man that is Keeling, that is a researcher of the NOAA, and thanks to the presence of some scientific instruments in the Mauna Loa Observatory in Hawaii, the concentration of CO2 in the last 70 years, from 1950, 1960, something like that. And this graph of the last 60 years that is measured, not reconstructed from the CO2 in the bubble obtained in the ice, but this is measurement observed. You can see an impressive increasing. Now, and this slide, every time that I made a presentation of this theme, I must update it because I have a similar presentation in March, and I wrote now 417 ppm. Now we are in 419, so it's quite huge increasing considering the time frame. We can see that after the Second World War, the concentration in atmospheric CO2 going to from 300 or something like that to more than 400. And it's interesting, this curve, because it's plotted with the emissions. So, okay, the concentration is the quantity of CO2 in the air, but how much CO2 we emitted? Because if the concentration has rise up, but we block our emission, okay, we hope that in some years the situation decreases. In black line, you can see the emissions, and the emissions rise up in a very, very fast way. So the concentration rise up, the emission rise up. You can see it is very interesting. In the last, this data is considered until to the December of 2020. You can see in the emissions, not in the concentration, a little change a little inversion in the quantity of emission. You can see in the black line. Now, that variation is not given the fact that we are okay, we change our lifestyle, we modify the emission of CO2. No, it's connected with the pandemic. In 2020, everything stopped, and then transportation are blocked, so everything is blocked, and the emission, not the concentration, the emission rise down, but actually is this gap is not so visible because completely overrated from actual situation. So the concentration continue to rise up, and it's interesting find how we can emit CO2 in the atmosphere. These graphs represent the CO2 emission by fuel type. So what we can burn for producing CO2, and it's interesting to see that coal is the main is the main fuel type, and then oil. The problem of coal and oil is not only correlated with the CO2 emission, but only with the particulate that emitted during its burn. So it's another problem that I don't want to present, but I think that it's interesting to show you. Okay, so CO2 increase due to the burn of coal, oil, gases, etc. But there are different activities that cause an increasing in CO2 emission, and causes are not so known. So I think that it's interesting to show you. Deforestation is another cause of CO2 emission. The scientists estimate that more than 50% of greenhouse gases, there is an increasing of 50% of greenhouse gases due to the deforestation. You think a situation in a forest, you think a situation in a cleared land, there is a strong difference in the emissions of CO2. And the deforestation is not something that starting in the last 50 years. Do you know that since Middle Ages, deforestation starts in an intensive way to modify climate? Even since the Roman period, deforestation starts to impact on the climate. In this graph, I can show you the million hectares deforested since the Middle Ages. You can see that in the temperate forest, particularly in the Europe, we can find that the intensity of this forest, the deforestation, and so the intensity of the modification of greenhouse gases due to the deforestation is higher in the Middle Ages than now. But why? Because now there's nothing to deforestate in some part of Italy. It's not part of Europe. If you think we are in Italy, the Po Plain that actually was a conurbation of house, farm, and so on during the Middle Ages was completely covered by trees. So is not a positive data. This is it can be interpreted as not a positive data. So the influence of on climate, so on the CO2 concentration, is not a brand new thing that occurred only in the last century. There is another important factor of emission that is not connected with the burning of coal or something like that, is intensive farming, because cows and other animals have, and I don't say you how, emitted large quantity of methane. And this is a problem if you consider in some parts of the world where this intensive farming is often connected with deforestation. So we have a coupling effect in the increasing of emission. These latter two cause of emission are not so important in the total budget, but are very peculiar that the activity of the mankind has on climate change. Okay, all these emission of CO2 obviously have effects, first of all, on the temperature rising. The temperature rising is the first effect, is the main effect of climate change, of the CO2 concentration change. The effects of the temperature rising is that the current warming trend, and we talk about trend, not absolute data, is proceed at a rate not seen over many recent millennia. An increase like that, temperature rising like that, is not seen from millennia. So this is the important fact of global change. I think that this graph is more famous than the other one that I present since now. We can see the anomalies in the last century and a half. We can see that the increase in the anomaly in the last 40 years is harder and harder, and this is greater and greater, and this anomaly is not connected to weather situation, connected to the weather variability. If you consider these anomalies, you can see on there are some spots, okay, that spots that more hotter or more cloud spots are connected with the weather, not the climate. But if you continue to see the videos, you continue to see the this GIF, you can see that this is not a weather variability. The situation that is now is connected to a climate variability. Okay, if you can see a blue spot in the Atlantic Ocean between Great Britain and Iceland and Greenland, this is maybe connected with a weather variability, because in that part of the world something happened, maybe connected with different movements of the water. I don't know. I don't want to. I don't know how, but if you consider the globality of the world, the situation is clear, and I think that is no doubt that something has changed. Another data of the effects of the climate change is connected with the temperature rising. Again, I show you the 10 most warm year of the last 150 years. The 10: 2013, 2010, 2014, 2018, 2021, 2017, 2015, 2019, 2020, 2016. These are the 10 warmer years of the last since 1880. So if we consider that every the oldest year of this is 2010, you consider that the global change, the climate change, is not correlated is not so is not a long problem. 2022 is not present here because it's not concluded, but now actually is in the first place. So another place was another year was was present here. Okay, now let's move from graph to images. We know that I work on glacier, and glaciers are the most spectacular effects of the climate change. I can obviously I can show you images like this, and I can stay here for showing images like this until the 1st of September, because if you compare two glaciers, the glaciers in two periods of the last century, the situation is the same. This is I show you some the most wonderful, not interesting glacier of the Alps and on the world. This is an example of for the central Italian Alps, Fellaria Est. Another one is the Forni Glacier. Forni Glacier is one of the most studied glaciers of Italy. It's located in the central Italian Alps. On the left, you can see an image of 80 something in the last part of the 9th century, and on the right you can see an images of 2012 and 20. But the situation is not typical only for Italy, for Alps, obviously. This is the Uppsala Glacier in Patagonia. This variation is occurred in less than 80 years. Or also in Alaska, the Muir Glacier from 1899 to 20 and 30. The difference is impressive, is dramatic. The last one are two glaciers of Caucasus, Saneri and Kasebi, sorry for the pronunciation. And I want to show these two glaciers because we talk about climate change connected to the glacier to a unique way, glacier retreat. Okay. But where glacier retreat, something happened. You can see that where a century ago there was glacier, actually there is a forest. So in that case, you don't consider only the worst scenarios, only the worst effects of glacier retreating. And glaciers changes not only in the length, not only in the mass, but changes also in the characteristic. And then I can show you some problems correlated to the glacier recession and to the glacier retirement. Glacier change in mass. This is a quantification of the variation of ice, of the mass of the ice in the total world, in the whole world. And if I say you that we lost more than 330 gigatons of kilos or gigatons of ice, it's a nonsense number. I think that it's different to quantificate. It's complicated to quantificate. It's impossible to quantificate. This variation in mass can modify the velocity of the Earth rotation. So the effects are important. This mass is so high that can affect also the rotation of the Earth. So the mass is impressive. The variation is in the length, and this is most spectacular. I present you some glaciers of the Italian Alps. For example, you can see that Aletsch Glacier, that is the larger glacier of the Alps, suffer a land change of more than at least 3 kilometers. So many a huge area that was completely deglaciated in more than a century. This connected to glacier change, there is another effect, that is mean sea level change. Glacier change, mean sea level change, I put a question dot after this statement, because the variation of the mean sea level change that is reported in this graph on the NASA, and say that in the last century of 120 years, we the mean sea level change rise of about 20 millimeters, sorry, 200 millimeters, 20 centimeters. The variation of global of the mean sea level change is not connected only with ice melt, because if we consider the global mean sea level change, not only the ice melt is a key component, but we consider also thermal expansion. If you heat a liquid, this liquid suffer as an expansion. This liquid expand in the same way the ocean water expand when it's absorbed the heat, and the modification in the land water storage. If you consider in the last century the dams that are constructed for blocking some many water in the land for the hydroelectric production, or the groundwater pumping for human activity. So the variation of mean sea level, the global mean sea level is not correlated only to the ice melt. NASA estimated that in the last, considering the time frame 2005-2019, if we consider 1.3 millimeters per year correlated to the thermal expansion, the mass increase trend, so the ice melt is responsible to 2.1 millimeters. So it's not, there is not an extreme difference between the component of ice melt and the component of thermal expansion. I give you a Arctic glacier, Arctic ice cap. Okay, the melting of Arctic ice cap doesn't influence on global mean sea level. It's the same thing that you put a block in the of the ice in your spritz, and for the foreign, I show you in the next slide. I show you where you can find a good spritz. If you put a block in the ice in a glass of water, the water did not go out to the glass. So the ice melt, we consider only the ice melts of the Antarctica, of the Alps, of the Caucasus, of Greenland, but not the Arctic cap. And the global mean sea level, we talk about some 20 centimeters, something like that it's not a problem. No? What is 20 centimeters of global mean sea level increase? But if we are here, this is Venice. Yeah, I think that here you can find a good spritz. I think that if you are here, 20 centimeters are a problem, because there are many people that live completely at zero on at the zero level, or in many cases under the global mean sea level rise. So the economical problem connected to the mean sea level rise are important, in particular in some parts of the world. If we are in Italy, for example, here we can map the area that can be submerged if this trend go down until go away until the 2000 and until the last of this century. So large part of the Po Delta, large part of this area will be completely submerged in at the end of the century. So in some part of Italy, in some part of the world, I show Italy because we are here. This is a very problem. Global glacier change bring another problem. Glacier change mean albedo change. Albedo is the measure of the reflection of the solar radiation out of the total solar radiation. So if you consider albedo of 0, you have a black body that absorbs all incident radiation. If you consider albedo to 1, a body reflects all the incident radiation. It's like this situation you can find, you can see easily if you go in a parking lot and you touch a white car or a black car. A black car is more hotter than a white car because the black car absorb more efficiently the solar radiation. Glacier ice have an albedo of 0.6, 0.5, depends on the condition. So more than if albedo is 0.6, like I show in these images, the 40% of the energy is reflected. So it's go away. The terrain has albedo of 0.15. So the 85% of, if the albedo is 0.15, the majority, the 85% of the radiation that comes from the outer space is absorbed. So the difference is very important, 0.5 to 0.6. You've seen that the terrain, the deglaciated terrain, absorbed 4 times the energy that absorbed the glacier. So the situation is very important. Not considering the small glacier, not considering the Greenland ice cap, because the Greenland ice cap, the albedo change because the Greenland ice cap is becoming darker to the presence of black carbon and something like that. The problem is here, is connected with the Arctic. In every year we lost a million of meters or square meters of ice that have a completely different reflection, a different albedo, different from the water. So if we lose ice, we lose the capacity of our planet to reflect the radiation, and we gain more possibility to absorb. Is to absorb this radiation. So there is a sort of feedback, because smaller glacier means higher absorption of energy. Higher absorption of energy means higher temperature. That means smaller glacier. And so the circle is a never-ending circle. So scientists hypothesize that in the next 20-30 years, during the summer, the ice cap, the Arctic ice cap doesn't exist. So the problem is connected to the glacier, but is not only given by glaciers. Glacier change means risk increasing. This is dramatic images of Marmolada Glacier collapse that occurs on 3 July of this year, that have caused 11 fatalities, and that I think that have changed also then our perception, not our maybe of the public, main public perception of risk connected to climate change, or of risk connected to working and living on mountain in this climate change situation. And this increasing risk means, in particular here in the Alps, means decrease in tourist in presence, decrease with a lot impact also in the economy of how this area. In the Alps, in the Southern Alps, during this winter, the summer, the snow was extremely reduced, and many skiing activities are closed during the winter, and that effect is very important for the economy of some parts of the world. That is not so dramatic if we consider the more dramatic scenario of the climate change, but these effects are now and can touch directly many people, because lost in that case lives, or lost also works or something like that. As I can see before, glacier change means also a change in the characteristic of the High Mountain, not only increasing the risk of the frequentation, but also considering the presence of the biotic colonization. Now, high mountains are more greener than 100 of years ago, because this is if you can see this image of 2004 and this image of 2021, we can see how the larches, that are all larches, start to recover the area that the deglaciated area. So this change is not only a negative change, but in some situation we can observe some positive change, like the expansion of the forest. Climate change is not only connected with glacier change, but it's connected also to different situation. One of that is a more frequent extreme weather events. In this graph, they try to plot the number of events globally, the number of extreme events globally that occur globally. This is not simple for reconstructing this graph, because now every hail episodes, every tornado, every extreme weather events, there are many smartphones that recorded, that filmed a photo, that bring information about this event. In 1950, if we are here in Courmayeur and 50 kilometers away from here occurs something extreme, I don't know if we know that something has changed. So this is not a simple reconstruction of an increasing flood, increasing storm, but it's physically simple to explain, because if the atmosphere is warmed, the energy is higher, and so the extreme events are more probably. These extreme events obviously have a large impact on the economy, a large impact on in particular in some part of the world. Italy we have some problem also with this kind of extreme events due to the conformation of our peninsula that is fragile considering the orographic situation. So this is not the higher frequent, a more frequent of extreme weather events is not so clear, these trends, but we can assume that this is occurring that. And concluding, I want to say that the last chapter of these changes, that is changes correlated to the loss of biodiversity. This is, if we consider climate change connected to loss of biodiversity, maybe we can see something that is away, far from us. Okay, the climate change modify habitats. Habitats can cause loss of biodiversity, extinction, something like that. This is maybe not a wonderful mammals of the world, but this is Melomys rubicola, that is a species of rodent, a small rodent, that is endemic of a small island of Australia, located between Australia and Indonesia. This island is characterized by a maximum elevation of about 2 meters. It's a sort of bar of sand, and the Melomys rubicola lived here because the increase of sea level rise, the increase of extreme weather events connected to the ocean flooding reduce dramatically the vegetation of the island, and this rodent was classified as extincted in 2009. This is known as the first described extinction connected directly to the Anthropocenic presence. Okay, you say that we can live without Melomys rubicola, but Melomys rubicola is one of the can be a sort of paradigm of this loss of biodiversity. This is more, no, it's better than Melomys, I don't know, but it's golden toad. This is golden toad that was, and I use the past, abundant some years ago in a small high altitude region of Costa Rica in South America. It lives in cloud forest areas where there is a high humidity, where this climate characteristic favor the presence and the reproduction of the golden toad. In the last 40 years, climate change have modified this environment because drought periods are more intense, drought periods are more frequent, and this animal, golden toad, was declared extincted in 1989. Probably is not only connected, it's not connected only to the climate change, but the climate change give an important reason for the extinction of this of the golden toad. The big five. I don't know if you never see or never see something like about big five. Big five are the 5 episodes of large mass extinction during the Phanerozoic. Between Ordovician and Silurian, between the end of Devonian and at the end of the Permian, the most famous, between also between Triassic and Jurassic, but the most famous between the Cretaceous and the Paleogene, with the extinction of the dinosaurs. That are the big 5 episodes of large mass extinction. And as you can see in these last 500 billion years, we can lose in an occasion 80% of species, 65% of species. The extinction between Permian and Triassic, that is dated 250 million years ago, lost 96% of species, and was the worst extinction of the history of the Earth. Now, someone in the scientific community start to talk about a possible sixth extinction connected to anthropic pressure and climate change. This is not, I don't show you data, I show you, on this case, a projection, but if the situation is going, is not changed, our emission of CO2 and methane did not change, the climate warming did not change, the sixth large mass extinction could be possible. And something, I show you two examples, something has already happened. So for concluding, I want to say you that I don't try to convince the climate change exists, because climate change exists, I show you in the second slide, is a scientific fact. And if you read the first papers dealing with climate change that was written 30, 40 years ago, we now see what scientists have predicted in that time. So, such as the loss of the sea ice, the melting glacier, ice sheet, the sea level rise. So, the climate change and the effect, and the more dramatic effect, are actually occurred now. The situation is that scientists predict that this global temperature increase due to the human-made greenhouse gases will continue a lot from a lot of years, and severe water damage will also increase and intensify. So the problem is here. The problem will be more greater, in particular in that period in the last 2 years that caused that the global warming is not the main problem, because we have war on the planet, we have a pandemic situation on the planet, so we have many problems, and the climate change became not the most important or the most emergency problem. But this situation is real, and this situation is given their worst in the next year. So now I have concluded. Thank you for your attention, and if you want to ask you something, I'm here. Okay, I have read this. Do you see also you? No? There is a question that from a website I found that during greenhouse period there was a huge increase in life, such as dinosaurs. Does global warming really have a positive impact on organism life? Global warming is not a problem for the heart, because the Earth, in some people of the Earth history, we have more than 15 degrees higher than now. The problem is for us, for our society. The Earth doesn't make a problem with 1 or 2 or more degrees. The problem is correlated to our society, to our lifestyle, to connected to the problem of some part of the world where an increasing of 2 meters of sea level rise of sea level, some migration occurs. So the problem is not saving the heart. The problem is saving our society, our lifestyle, from the climate change, because the resilience of the mankind is not so high, and so it's not so high as the Earth one. So yes, considering, if you consider the period of the Carboniferous, for example, where the concentration of CO2 was 10 times higher than now, we can see some plants that now are, some trees that now are tall a few meters, that are higher and more and have a positive impact. But the problem is connected to our situation, to our society, and in particular to the now 9 billion now, 9 billion or 8 billion and a half people that live on Earth. So there are two different levels of problems connected to climate change. The problem, why we might, Kevin from Indonesia say that, ask that why we might not able to reverse climate change, is the Earth currently past its tipping point, and can we know when we pass the tipping point? So the reverse climate change is not a simple situation, because as I show you, the emission of CO2 are increasing. So the first step is to reduce the increasing of CO2. After reducing the increasing, we can arrive to a zero CO2 emission. After zero CO2 emission, the concentration of CO2 can start to change the curve and start to become lower. So you think that the problem is not so easy to involve in. Some parts of the world have reduced since the beginning of since the last 30 years, have reduced the CO2 emission of 30%, 35%, but in some parts of the world, due to these not have occurred. So the problem, this is not a simple problem. And if we consider glacier as an example of one of the main evident effects of climate change, we can modify the emission, reduce the emission. Then after reduce the emission, the concentration of CO2 start to decrease, the climate so start to cool and became more cool. And after that, glacier start to gain a mass. So it's a long way to restore the situation of the little ice age that ended in the last 2 centuries. So is the situation is so complicated to reverse the temperature trend. Voi vedete. So ask that something like bacteria being used to consume carbon in the oceans. I don't know this. I don't to say something that I don't know. The problem of there are many researchers that work on the extraction of CO2 from the atmosphere, but now these processes are very onerous, it's complicated, and is limited to small fraction of CO2. So actually, is not the solution. Reduce the concentration in that way. As those become more frequent and extreme, will we start transitioning to a two-season year, dry wet season in the entire planet? I think that entire planet, no, or better. When this occurred, I think that was completely a dramatic situation, but in some parts of the world, this two-season a year, so a dry wet season is became more frequent, in particular in the Mediterranean area. In Mediterranean area, in the last 50 years, in the last century, this variation is more intense. We don't consider that this year that is particularly hard year, but in some parts of the world that are characterized between that are the boundaries of the dry wet season to a more complex situation is just happening, particularly in Mediterranean area, because I know in the south of Italy in particular. In the entire planet, I hope not. And with the lack of water, how will food production and human activities be affected? Are there solutions in place? The lack of water is a problem connected not in all parts of the world to the glacier, because the glacier fed water in some part of the world, in particular on the Himalaya, on the Karakoram, not in the Alps. Glacier in the Alps are not the main, and also in the US, are not the mainly sources of water during the summer season. But in some part of world, this is the problem, and solution. If I have solution, I think that is not simple. Are not simple to find solution for this question, but in particular, it's important to reduce where is possible the consumption of water. I use Italy as because we live actually in a moment that we have a scarcity of water, and there are many activity to preserve water. So starting to this and starting to change in some part of area, the characteristic of cultivation is very useful, because in particular in Italy, the corn culture is very diffuse, but the corn culture is a culture that is characterized by a huge consumption of water. So changing the characteristic of agriculture is one of the solution of this. What possible effect could global warming had on the biosphere during the Pleistocene-Holocene boundary? Yeah, in some parts of the world, the effects are intensive, extremely, in particular where near the alpine alpine chain, or near many parts of the world, because during the Pleistocene, glacier cover a higher part of the world respect to the actual situation, and so the biomes are completely moved. The situation was completely different, and so also the biosphere completely different. So it's difficult to compare the situation, the biosphere situation, the actual biosphere situation with the Pleistocene biosphere situation, because the difference in particular in some parts of the world are extremely high. As oceans are the primary sink for anthropogenic carbon emission, what is the upper limit for that in years or amounts after which it will be unable to do so? Yes. Not only the oceans are the primary sink for anthropogenic carbon emission, but the alteration of one of the main sink is the alteration of carbonates in some part of the world. That, in particular, on an Indonesia area, that alteration brings CO2 to the that was buried. So, but it's a natural cycle. These the effects of oceans, the effects of chemical weathering of carbonates is present in a natural cycle. The human puts CO2 in this natural cycle, and this natural cycle starts to is not balanced. So the problem starts with this input that is higher than that oceans can sink. So the problem is the input, not the output. Wow. Is there any relation between global warming and the frequency of epidemic? I don't say nothing about that. There are maybe 2 papers that hypothesize that the glacier reduction can liberate some virus or something like that, but I don't know. I hope not, but I don't have the competence to ask to your question. I want to know what's the sources of sea level rising. Is it cause of melting the glacier in the oceans? So that one exists in the continents, in particular the melting of the Antarctica, of Greenland, of the third pole, that is Himalaya and Karakoram. The glacier, the floating glacier, for example, for the Arctic ice cap, did not modify the level of sea level, the sea level. So the main topic is connected to the glacier in the continent. Why the climate change has decreased the amounts of tropical cyclones that included in extreme weather, but just increased the intensity? Shouldn't there be a match between them? I don't know if there is a correlation. I don't know if the climate change reduce the amount of tropical cyclone. Obviously, increase the intensity, because if you consider a more hotter situation, the energy that is present in the system is higher. So obviously, the intensity of weather events are higher. If you talk about that climate change has decreased the amount of tropical cyclone, I don't know if there is a correlation, but there is a correlation of the increase in the intensity, and this is evident in many papers.
Okay, thank you so much, Professore.
Thank you.
And thank you to all who are present, even virtually, to this Lectio Magistralis. I hope that the subject could be interesting to everybody. You have a lot of suggestions to work for your Earth System project. And thank you also for the question. Very interesting, not easy, because of course we risk to link to this serious phenomenon a lot of other things that we need to study till now. So what I can say is to wish to everybody to continue to study and to keep science at your first place, because that's what we need. Okay, thank you so much. We are Italian group is now moving to the edge of the Mount Blanc, and we promise some nice movie as well. Okay, thank you and goodbye.